Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are in the second part of the session on basic functionalities using data frames. And here we just go for the topic filtering. So let me just move on to the part 2. Dear friends, we saw in the previous session how it is possible to select elements within a data frame, and of course we have also discussed some things related to series by specifying appropriate spatial indicator such as labels or numerical positions indices. And in this part, we will going to discuss the very similar operation which also selects, but it totally focused on the values of the elements, which we just say it as filtering. And dear friends, in this case, we will set a particular condition in the selection designed to select only the elements within the value. So that satisfies them. So there is therefore filtering of the values of a data frame. So that is what we are just going to discuss now. And of course, this filtering techniques is therefore based on a particular condition, and that particular condition is Boolean condition. Okay. So, of course, dear friends, which is nothing more than a Boolean expression, that is mathematical expressions that results in a true or false. For an example, if we just specify anything that is x is greater than 5, or what is the values, whether it is related equivalent to 5 or not. If the condition is satisfied, it will return true, otherwise it will return false. Okay, now let me just move on to the concept that is filtering on the lines. Dear friends, the most initiative filtering is filtering on lines. So that is the one that will pass only a few lines of the data frame based on the Boolean concept. So kindly just have a note of it. First let me just create a data frame. And here is the data frame, and of course we are just going to create a data frame of random values between 0 to 1. So here we just go, so pd dot data frame, and here let me just create it with random of something related 40. Okay, so over some 4 columns. Okay, so let me just reshape. Or 10, 4. And of course, we want to include one thing, that is columns 2. So here we just go with the columns. And last but not least, okay, so here it is the data frame, and let me just print it to get it executed. So we will define a Boolean condition based on which the selection will be made. So for an example, if we want to filter only those rows of the data frame that have the values of column A, which is greater than 0.5. Okay, so since these are on floating values, let me just make it as like 0.5. So here we just go with data frame, and this is the A column. Kindly just observe, it is greater than, I just want to make it with 0.5. Okay, so kindly just have a note of it. So as a result, we got a series of Boolean values. Just observe, dear friends, we just got a Boolean values, and we can easily see that only a few lines met this condition, which we just got only true, only few we just got. And at this point, we will pass the Boolean condition to our indexes operator. So we will perform a filtering of a data frame with the passage of only those rows that meet the requirement. Okay, so that meet this filtering process. As an indexing operator, we use the one represented by two square bracket, that is which we just made use of it, and this operator will take care of the passing only the row corresponding to this true condition. So that is what here we are just going to take, which is only the few. Okay, so based on the indices, so kindly just have a note of it. I'm just going to take this as our selection, that is the filtering. And now I want to make this as one of the data frame. So see here, this is the data frame I want to create with this condition. Okay, so with this condition, I'm just creating the second data frame, and kindly just have a note of it, how it seems. So see here, dear friends. So this is how you are just making the filtering. But you can also use other indexing operator. You can also make use of that indexes LOC, that is the location. That also you can just make use of it. So I just make that option also. So kindly just have a note of it. This was LOC, and within that, let me just pass on to this, and here let me execute it. So yeah, the result is of course pretty much the same. Okay, fine. Yeah, dear friends, let me just move on to the next filtering on columns. The complementary case to the previous one is filtering on columns. So in this case, only those columns of the data frames are filtered, so whose values meet certain requirements. Again, we will define a Boolean condition for an example. So kindly just have a note of it. Here I just want to make df dot mean, and yeah, dear friends, till now we have not discussed what is this mean or mode or related to the statistical function. Yeah, let me just make it in the next further sessions. But before that, I just want to show you the condition. Okay, so here kindly just to see, I want to make a Boolean. So we want to select only those columns whose average of the values is greater than. So average of the values is greater than 0.5. And here I just provide it. So that 0.5 average. So see here, from the series returned as a result, we can see which columns meet this condition from the element with the value true. So we apply this Boolean condition to indexes. That is also it's possible. So yeah, of course, let me just make this as 4. You can also make the same thing by using LOC, and kindly just observe, I'm just going to make this condition as one among the filtering options. Okay, and let me execute the df4. Oh, I got an error. Just as, from every rows and columns I have to include that also. Yeah, see here, dear friends. So as we can see the result, only the columns that met the requirement of the Boolean condition will be passed into the new data frame. Okay, will be passed into the new data frame, that is df4, which we just done it by filtering method. Okay, now of course, yeah, we have just seen with only one condition, yeah, applying with multiple condition. Of course, dear friends, yeah, you have to make use of the AND operator. I'm just going to give AND operator, and for OR operator, of course, yeah, you can also make use of NOT operator. Okay, so let me just make use of in filtering, you can apply several Boolean condition at the same time. So to do this, different condition can be applied at the same time. So here we are just going to make use of some logical operator as AND or NOT. Okay, so every single condition is enclosed to the same thing as like a square bracket and joined together to the previous logical operator. So let me just make one condition. So that exact condition from the one single column, that is A, and I just want to fetch which is greater than 0.3. Okay, so this is one condition. And second condition, the same column that should be, yeah, greater than 0.7, anything. Okay, so it should be less than 0 or so. So now I just want to make it as like a combination of the both. So kindly just observe, I'm just going to make it with any one of the condition if it is satisfied. So kindly just observe, dear friend, applying it on an indices, how it would be. That is also, let me just see. So see here, before making into this, so this is how we make use of one or more condition. Okay, so let me just apply the same thing. I'm just going to copy this and let me apply on to a new data frame. I'm just going to form a new data frame. So here, this data frame should make use of this functionality. Of course, I'm just going to make copy of already copied. So let I just execute this one by making a print session. So yeah, print of df5. So kindly just observe, dear friend, how this exact happenings. So I think every values, it is less than 0.3 and of course it is greater than 0.7. Any one of the followings, it just gives the value. And if the same Boolean condition are often used within the code, yeah, it would be a good practice to first define them as variable and then use them when necessary. Okay, so that is also possible. And of course, dear friends, one among the functionalities related to this concept of filtering is Boolean reduction. So there are a number of methods called reduction methods which allow you to obtain a reduced results as like the function any, or you can just make use of all function. Okay, so but let's just say some example by clarifying the function. Dear friends, actually we apply a Boolean condition in which all the elements of the data frames are evaluated. For example, if we want to know which element of the data frames have a value greater than 0.5, how we just make use of it? So 0.5 or 0.1 or whatever thing. So here I'm just going to show you this is what. So that is df greater than 0.1. Okay, so this is how we just seen, and let I have execution of the same. So this is how. Okay, so in this case we got a data frame full of Boolean values. Kindly just see, everything are Boolean values, and a reduction method can be applied to this data frame such as all. Okay, all method to know if each column or within each column all the values meet these requirements. And kindly just have noted, all should be true. So in that manner, kindly observe how I am just going to make use of this is, I am going to pass this functionality as separate. Maybe you can also have use of df6.all. So kindly just have a note of it. So whereas the any method that has the opposite behavior. See, opposite behavior is, that is, it allows us to know if it is context of each single column. So that is at least one value should be satisfied and the condition it should be true. Okay, so here let I just make any of that function. Okay, so kindly just observe. And an interesting thing in when we apply the any method, if we just applied it twice, a single Boolean value is obtained by confirming at least the presence is the entire data frame of a single element that satisfies the condition. Yeah, let me just have that look also. If you just make it any and again twice, if you just use it, yeah, of course. We just get it obtained by confirming at least once the presence is entire data frame of a single element that satisfy the condition. Got it, dear friends? Okay, now another method of filtering is isin. So this is an isin method. Okay, so this method lets you know if one or more element are present inside a object such as a data frame or series. Okay, so in this regard we define an example data frame and let me just make it predefined. Okay, so let we create one of the data frame here. Let we make it pd.dataframe and let I just make it with an array or a range of 9 and let me just reshape it with 3 into 3 matrix, and of course I just want to include the columns too, and here the name of the column, 3 columns which I just want to specify is A, B and C. Okay, so let me execute it and let's see what is the df7 here. Yeah, now let's apply the isin method with some values to search for it. Okay, so search for something. So here let me just create a new data frame df8, and yeah, I want to pass the previous data frame df7, and let me just make it an isin method. And yeah, here let me just pass some list of values. Okay, so 0, 3. Okay, so let me just execute it by df8 and kindly observe, dear friend. See, as we can see that by passing a list of values as an argument to the isin method applied to the data frame, we get a Boolean data frame of the same size, which we have true if the value belongs to the list and false if it doesn't exist. And of course, dear friends, we can see this is also one among the filtering operation. Thus, passing this Boolean data frame to the indexing operator, you can get a filtering of the values in which only those which corresponds to true as a value will be passed, and which all the other, if we just specify, if we just get it corresponding to the values of false, of course we would just get it as like NaN, which is not a number. So let me just make it on to the data frame here. So df7 of df8. Kindly just observe. So then it will be up to us to decide how to handle this NaN. So this is a not further classification, further more whether the data is missing or not, like that. Okay, so see here, this is how you can just make use of the filtering functionality. And yeah, dear friends, next it's the topic on editing. So kindly have a note of it. Let me just start it on editing. And what is this editing is in the sense, dear friends, actually in this previous section we saw how to select some parts as parts in the sense some subset of a data frame to view them and to extract them as a new object, whether that object is a series or data frame or more often. Okay, so to manipulate them later operating on to the values in some way. And another basic operation that is carried out is that of editing. That is, once you have created a data frame with a constructor, yeah, it will be necessary to make changes to its structure. So sometimes it will be necessary to add at the end, or even it need an insertion or any new element or such as rows or columns and other items. Yeah, it will be necessary to remove entire rows and columns too. Okay, so yeah, in this part we will define or we will discuss how to deal with the editing of a complex object such as data frame here. Yeah, let me just first go on to adding. Okay, so here we just go. So you will have to understand by now that due to the way the data frame was structured within them, you can think the column as separate series. Okay, assembled together to form a data table. So the editing operations of a data frame working on the columns are somewhat easier. Okay, so let me just create a data frame here. So yeah, this is what the data frame. Okay, and yeah, kindly just observe. Let me just make it as a one among this, and of course 4 5 6, let be the next one as 7 8 9. So these are the exact elements, and yeah, we just going to make first one, we need to make the index, of course. So let me just have it 3 indexes as A, B and C, and of course the next one is the columns. Yeah, we are just going to differentiate with an uppercase. So this is what. Okay, now let me just print the data frame. So here we just have the data frame as 1 2 3 and 4 5 6 and 7 8 9. And here, dear friends, I just want to add a column at the end. Is a fairly simple operation. So it is sufficient to select a column that does not yet exist. So specify a new label within the index operator and enhance it in some way. So in this way, a new column will automatically, okay, and automatically be created, which will be added after the last existing. So kindly just have a note of it. This is what I just don't want to make it. So that is which doesn't exist. Okay, so here I just want to make it as like 17, and kindly just see every element of that column would be 17. So let I just print df. Kindly just see here. So from now, if you select this column, the behavior will be the normal selection behavior, where the returned value will be as like a series. That is also okay. Fine. Yeah, if we want to create a new column with different values instead of a single scalar, yeah, we can just pass a list containing all the values, but kindly just observe, yeah, you have to know what is the number of indexes here it is present. So yeah, I'm just going to include one of the column, and I'm just going to pass a list here. So 13, 14 and 15. Okay, so passing a list containing all the values, and let me just see what is the df here. So this is how. In the same technique can be used to update the values of an already existing column. So for an example, let me just pass the list of values to all to an already existing column. So here let me just have an existing column. Let me just move on to the D. Okay, so here I just want to make something updation. So new updation. So kindly just observe. I'm just going to give other than the numeric. So here I'm just going to make this one, and let me just have the df. So see here, dear friends. So how it has been updated with the new elements. It is what that you are replacing those already present elements with a new. So to enhance a column, you can use a existing series instead of a list also. And yeah, you can also make use of something with a series. Let we make this as a series here. So pd dot series. I just want to make it like, kindly just observe 11 and 12. Okay, and here I'm just going to give the index as, yeah, kindly just observe already existing index. This is what already existing index, and here df of D, I'm just going to give the SR. And now observe what is the df here. It is 10, 11, 12. And dear friends, yeah, another very useful operation is removal of a column from a data frame. And here we would use delete. Okay, so del as the keyword on exist. So that can be used for this deletion purpose. And kindly just have a note of it. If I just want to make use of this del as the keyword in the data frame, okay, df, and particular onto the column e, and kindly just see this is the e. And once for all deleted, kindly just let me know. Yeah, of course the column is permanently removed from the data frame, but there may be cases where the removed columns want to be preserved in some way. Okay, so the pop method allows you to remove the column from the data frame and return it as series that can be stored in a new variable. Okay, here the SR is the series, and I'm just going to take it from the data frame df, and let me just pop the column. Kindly just observe, dear friend, I'm just going to pop the df, that is d column, and let kindly update the data frame here. So see here, dear friends, and do you want to know where the exact series is there? Yeah, see here, I just let you know the print type of ASR, and kindly just see, yeah, it is the series, and yeah, it just have what is the column D had. And another useful method for editing a column within a data frame is the insert method. And this method inserts a new column within a data frame. And yeah, let me just make it with an example. So here we can insert a series we extracted earlier with the pop. Okay, so back to the data frame which we have just made it in the position 1, and let me just call it as label z, okay, to make it a differentiation. So all this is passed to an argument insert. So kindly just have a note of it. I'm just going to insert by using the insert method, and I'm just going to make it with the position 1, and its column name is z, and from where the source is SR. Okay, now once on passing this, kindly just have a note of the updated data frame. So see here, dear friend. So this is the position 1. Of course, you all just know that the exact column, it just starts with the index 0. So now the position 1 is Z. So the same insert method can also be used to copy a column within a data frame. So how it is possible? Yeah, let me just make it instead of a column. The column to be copied is passed instead of an external series. Okay, so kindly just see here, this is what. Let me insert at the third position. I have to provide the third position here, and yeah, I just want to make it as like a copy. So I'm just going to make it as a B2, and from where the source is df of B. Yeah, of course, we are just going to copy the B, okay, the column B from the data frame df, and we are just going to insert it add to the third column. And yeah, to be the thing, kindly just observe. Yeah, kindly just see here, the B column has been copied and it has been inserted in the third position. So yeah, dear friends, till now we have just seen about the adding, deleting and inserting a column. So let me just explore few things related to the rows. So yeah, so the same thing, let me have the df here. So I just copy the previous data frame which I just made it for the editing. So here I'm just going to make this as df2, or okay, so this is my data frame 2. So let me just take this as our data frame. Yeah, so we saw that in using the columns we are privileged because we largely exploit the internal structure of the data frame, so which provides the column as a series. So just call a column with the corresponding label to get a series. So it is possible as like by, if you just want to make a print of df2 of a. So kindly just see, this is what. So this reality has been pushed into the syntax within the library to point of the considering the column as a real attributes. So without even using this, without even using the exact indexing operator, that is anymore we want to just, we can make use of the attribute itself. So kindly just have a note of it, dear friends. So I'm just going to make, this is my data frame and here it is the column. Okay, so in the both the case the results are identical and we get a series as return values. Okay, so now, but in the previous section we saw that the indices are powerful tools that allows us to work smoothly within rows and columns. Okay, so let us use the indexer LOC functionality. Okay, so here I'm just going to make use of that. So observe it, dear friends. So t here I'm just going to make it as the variable and df dot loc, and I'm just going to take the index a. And of course you're all known about that this t is also a series. So do you want to know it? Yeah, here it is. So here the t is also a series. Okay, so it allows us to extract the row of the data frame as a series in a similar way to what can be done with columns. Okay, so you can also then add a row in the same way as for the columns. Okay, let me just make use of this. First of all, here we just go with the data frame. This is our data frame, and kindly just see here, dear friend, to this data frame 2, I just want to include a row that is with an index d and of course the element with 12. And the symmetry response, kindly just observe the symmetry with respect to the editing of the column, that remains unchanged and follows the same operation but using the LOC operator, that is the indicer. Okay, the same editing result will be obtained. Then you can change the values of the rows with the scalar values also by just passing a list or passing up any list of the values. Okay, so let me just see that also with an example. So kindly observe, dear friend. So here I'm just going to make df2 dot loc. Here, not only that new element, I'm just going to overwrite it. Both the operators are now I'm just going to do. So kindly just observe 10, 11, 12. So to the resultant, kindly see here the last row, which previously it was 12, 12, 12, and now it went on just passing on to the list with an element 10, 11 and 12. Here we have updated, that is changed by using a list of values. And of course you can change it by using a series that is already existing. You can also create a series here. I'm just going to make a series here. So this is what the series, and I'm just going to pass few elements, that is 13, 14 and 15. So this is the exact element. Let I just make this towards an indexes, and kindly just have a note of it, dear friends. This index, it's for the column wise. So I'm going to provide it in a uppercase. I have just provided it, and let name to this index. I want to give a name for this index. So here I'm just going to specify it as an E. Okay, so what is next? Of course, I'm just going to include this, that is updating towards the existed. So here I'm just going to make it as an existed one. What's next? Let we execute the data frame which is updated. So kindly just observe. So previously in the 37th cell, the value of D here is 10, 11 and 12. And kindly just see here now, it is 13, 14 and 15. Yeah, now let me just make on towards the deletion. Dear friends, to select the row or column to delete, you have to specify the label within the list as the first argument. Okay, so this exact method does not act directly on the calling the object, but returns the modified object which must then be inserted into a variable. So yeah, here we just go with it. So this is what my new data frame, where from the existing df2 I'm just going to drop the method, that is drop the row. And which row? Of course, kindly just observe, I'm just going to drop it where the axis, that is index is a. And dear friend, I have to make the axis, yeah, you can just specify the axis is equal to 0. If axis is 0, then it would delete the row, and if it is axis is equal to 1, yeah, it will delete the column. So here of course we are in the process of deleting the row, so I'm just providing axis is equal to 0. And let me see what is the updated data frame. So see here, the row with an index A has been deleted. Of course, we can also delete the same thing by using the axis 1. So kindly just have a note of it. I just want to make use of df4 here from df3. Let I drop. Kindly just see. Here I'm just going to make A. I think for the uppercase A, yeah, it is an column, of course. Anyhow, I'm just going to give axis is equal to 1. So now let me just see the updated data frame. So see here, the A has been deleted. And dear friends, we can also delete multiple rows or columns at the same time, yeah, by just adding the corresponding labels. And yeah, we can pass it as like an list as an argument. Yeah, let me just have it. Let me make it in the data frame 3 because we have a few elements in that, or else you can just go with the data frame 2 also. So let me just have what is there in data frame 2. Yeah, it is what? So in that data frame, so I just want to delete, that is drop, of course, here multiple columns. Okay, so multiple rows. Let I just go for it. First of all, A and C, and of course the axis here it's 0. And see here, what is the updated df6? Yeah, here it's. And of course, dear friends, yeah, here we are ending with the editing process of columns and rows. And of course, dear friends, we dealt with the whole series of basic operations that apply to the data frame, and which greatly help in understanding this type of objects and how they work. And the concept of selection is very important because it allows us to focus our attention on the subset of the data type. And dear friends, this type of object often has a dimensional that are too large to be considered in their entirety. Okay, and in addition to the often insufficient selection, a filtering system that allows us to select only what meets particular requirement that come to our aid. Okay, moreover, in this session, we have also used various editing operations, and it was possible to better understand the functioning of the internal structure of the data frame and how to manipulate it to modify, extend, or remove the useless or unneeded subsets. And yeah, dear friends, if you want to take your learning to the next level and join us on the exciting journey, don't forget to hit the subscribe button and turn on the notification bell. Let's see you on the next session. Thank you, dear friends. Happy learning.